Okay, and Chetan is going to talk to us about persona-based assessment of software engineering student research projects. It's an experience report.
Yeah. Oh, this is strange. All right, good afternoon, everyone. I hope you can hear me. My name is Chetan Arora. This is a talk about our experience of innovation in software engineering student research projects that was done over 3 years with my lovely colleagues, some of them here, other in the pictures. So this was done at my previous institute, like I said, over 3 years, and I will try to cover all the relevant details in now 11 minutes, 30 seconds. And if something doesn't make sense, it's probably because of the party last night, which was really good. All right, so before I begin, I wish to acknowledge the people of the Kulin nations on whose lands we are gathered today. I pay my respects to their elders, past and present. All right. A little bit of context before all the innovation in software engineering student research projects. So we had 4-year bachelor students, and this was their 4th year or last year research project. And the end product of the research project is a thesis or a dissertation that they produce. And we had approximately or more than 100 students every edition of this research project. And then they are graded or assessed on this grading system, which is followed in Australia. You get a pass, 50 to 59, credit 60 to 69, distinction 70 to 79, or high distinction 80 to 100. But of course, if you don't get any 4 of them, then you fail. Right, so now I'm going to talk about assessment challenges in general across which are global challenges, most of them when you have software engineering research projects with students. First of all is diversity of projects. We see a lot of diversity in ICSE, right? Testing, most of the sessions are about testing, or very little about requirements engineering, or applied software engineering for cryptocurrency or blockchain, cybersecurity, and whatnot. So how do you cater to such diversity? And also there is diversity in terms of the type of projects. There are very exploratory projects in research and development, large research and small development, or very applied projects like small R and larger D component. And then when you have such diverse projects, how do you actually assess them objectively? So is a well-done systematic literature review, how does that compare against doing a survey with practitioners or building a software algorithm and evaluating it on a case study? Variability of student skills. So students show different kinds of agency, independence in the research project, so how do you include that into your assessment criteria? And then this is more specific, could have been more specific to the institute where I was working, but could be generalized in other contexts as well, which is the high stakes in the grading system. So the 4th year bachelor students were eligible for doing a PhD after completing that 4 years of bachelor's, provided they get a very high grade in that research project. So that means as a supervisor, you have a vested interest and a bias, because if you give a very high grade to your student, they would be your potential PhD student. And who doesn't like having lots of PhD students? So, awesome. And then we saw that there were lots of high distinction students from these courses, from these research projects. And also there is another side of this. Not all of the students are going to be your PhD students, right? They're going to go to industry. Now industry looks at these grades, wow, these are like high distinction students. That means they can lead a research project independently. And these are your project managers. And that means there is also institutional reputation attached to all these research projects. So that is a challenge, right? So this is the version 0 of the traditional model that existed before we began any of the innovation or improvement. So students worked with their supervisors for a given amount of time, and they were assessed at the end of it on the thesis that they submitted. So that was the only assessed component. That was assessed on overview, related work, research questions. So a final mark for each of these criterion was given between 1 to 10, totaling to 100. And like I said earlier, most of the students were getting a high distinction because they were graded by their supervisors. And also because there was only this one large assessed component, the feedback, a formal feedback to the students was left for until very late. Then I joined the institute, and they said, can you look into it? Because I came from industry, and maybe I bring some fresh perspective. And we started working together with my colleagues to get some improvement into the process. So the first was personas. So as the paper title says, it's personas. We looked at developing these personas at different grade levels. So at a pass level, you are a research-aware professional who can follow directions in a highly structured environment and a well-scoped project led by the supervisor. At the credit level, the student is a research-engaged professional who can perform research with clear boundary set and with limited directions by the supervisor. Distinction, research-capable professional who can lead a research project with scaffolds provided by the supervisor. And at high distinction level, a research-ready professional who can independently lead a research project with guidance of the supervisor. So essentially, if you look across this spectrum, the main difference is student agency and the support provided by the supervisor. So a high distinction student is ideally should be the one by the persona whom you are very confident hiring as a PhD student and also letting other hire as a PhD student, not yourself. So just getting these personas helped us address to a certain extent the variability of student skills and the expectations attached at different grade levels. Because students, by just looking at this persona, knew what is expected from us. Then we also built a very detailed assessment rubric, very closely attached to the personas on the previous slide. I'm not going to go into all these details. It's probably not readable as well. But we had 7 factors on which we built this assessment rubric against these 4 grading grades. Literature review, academic writing, research design, project management, artifact development, evaluation, and dissemination. I'm going to quickly highlight only artifact development. So while we were developing this assessment rubric, we were very careful of the flexibility or the diversity. The software engineering research projects are very diverse, so we cannot just expect them to build one type of artifact. It cannot be just a piece of algorithm or a software. It could be a UI or design or a survey well done. That could be your artifact, and that is what you evaluate. And I can tell you it's very difficult to build an assessment rubric for such diverse projects. Go ahead. I had a lot of beer yesterday, so I need some water. Yeah, so the assessment rubric helped us address the challenge to a large extent around undefined criteria for objective assessment and also the diversity of projects. So this is what we did. So this was the first edition of the research projects, which is we implemented the assessment rubric based on the personas, and we came up with this task-oriented portfolio assessment model, which is on your right here. So essentially what we told students and supervisors that you do your literature review followed by your research design, artifact development and evaluation, and these are all your milestones or deliverables. And in the end, they all come together for dissemination. That is the thesis. So there was not just one large assessment component at the end of it. There were all these deliverables on the way. And instead of only the supervisor assessing or grading the thesis, there were now 2 external, so external to the supervisory team and the supervisor involved in the grading process. But as you can imagine, there are always going to be flaws or some reflection on what could we have done better. And one thing was this assessment process, the grading process was very expensive. Because imagine having 100 students and then 3 graders for each one of them. It's very, very expensive. So there are a lot of organizational or administrative complexities around it, around workload. And then you also need flexibility. Once again, we figured that we cannot just ask people to follow this linear process for software engineering research projects because this is now how all the projects work. But this was our lesson learned for the first edition, and then we went ahead and did the improvement in terms of flexibility for the next edition. What we did was we used a previous model as guidance for the students and supervisors, but told them you are free to start from anywhere as long as you are consistently reporting on the progress of your project. And supervisors also gave twice intermediate grades to the students. So that helped with the flexibility issue that we had on the previous slide. And then in the third edition, we tried to address the issue of expensive grading process by having a central moderation panel with around 10 to 15 staff members who were reviewing all the theses in general. So that helped us address the issue of high stakes in the grades because there was equitable assessment at the end of it. It was not a perfect model, but it was much better than what we had in version 0 or the traditional model. All right, in terms of lessons learned and the outstanding challenges, so we figured out that the personas help set expectations at the right level for students and also for supervisors and yield higher level of agency in students. So we didn't really do an evaluation or interviews with students, but anecdotal evidence shows us that they showed higher level of agency, the students. Flexibility in the assessment model is a key because if you tell them, look, this is the sequential process which you have to follow, it doesn't always work. So you need to give this flexibility to students and also to the supervisors. The model is the whole model that we have built. I mean, there are much more details in the paper. If you read the paper, is generalizable and adaptable in different contexts. So now I am at a different institute. We will probably try to adapt it in a different context and see how it works. Now, the outstanding challenges, we tried to fix a lot of things, and there are still a lot of things which require fixing. So getting the assessment process right is very, very difficult because of a lot of factors. And one of the factors that is an outstanding challenge is the fidelity of process implementation due to the variability of supervisors. So not all the supervisors are invested at the same level in the projects or provide same type of support or feedback to the students. And also the fact that if a person inexperienced person like me comes in and says, okay, you have been a professor for 25 years, how dare you teach me how to supervise or grade my students? All right, so those are our lessons learned and challenges. Thank you so much. We are hiring at Monash, a senior lecturer and senior lecturer in software engineering. I am hiring a PhD student in requirements engineering for AI systems. So if you know requirements engineering is an underrepresented area, if you know someone who's happy to work in requirements engineering for AI systems, please send them my way. This is how you can get in touch with me. Thank you so much.
Thank you so much. We have time for a couple of brief questions. Yes, please.
So you went from a situation where most students were getting high distinction. After this process, how did the distribution look between the students in the multiple categories?
So the distribution went to what is normally expected, that is around 15 to 20% of them were getting high distinction. There were around 30% in distinction range, and then more in the credit range and some in the pass range. So the main issue was to get a PhD scholarship, they had to have a high distinction, that went more or less down from 75% to 20%. And then we were also, as the institute, we were very confident that if our students have a high distinction in this student research project, these are really deserving higher distinction students.
Yeah, it's just something that I'm a bit confused about. Is this for a thesis topic or is it for a team project?
It's an individual project.
Industry project?
Individual
project. Yeah, okay. Do you often get the people on high distinctions getting a conference paper out of what they're doing?
Yes. A workshop paper or a conference paper, yes.
Okay, great.
Sebastian Brock, TU Delft. I'm teaching a very similar course, and as such, I have more a comment rather than a question. So we were facing the same issues with how expensive it is to grade students, and I guess to complicate this even further, you want to provide them with formative feedback before you assess them, right? So you essentially have the whole process twice. So what we're experimenting with right now is actually using the students for like giving let them do peer review and like peer feedback to make this a bit more scalable. I cannot report on the results yet because I mean the course is still running in this iteration where we first apply it, but at least based on the feedback that we have received so far, students actually like that. So if you are already in the place where you have like really good and detailed rubrics, this might be something that you can also explore as an opportunity.
Perfect. Thank you so much. Yeah.
Thank you so much for your comment. Unfortunately, some of you might have heard my home desk remind you that it's time to give the stage to our next speaker. Thank you, Chetan. Our next speaker is Isabella.
Okay, thank you, Alexander, for the nice and kind introduction. And hi, everyone. So today I will show you what happens when you have a bunch of students in a room sitting there with also a lot of bunch of suites with limited time, and they have to do some task, and I can promise you it is stressful, and that's also exactly what we wanted to investigate with our study. So first of all, as you all know, software development is also about social activity and collaboration, and it requires teamwork. It is really important, especially nowadays with self-organizing teams. However, we also know, especially in software development, we face many stressful situations, right? So there are deadlines coming up, people are dropping out, or they're not doing what they're supposed to do. So this leads to conflicts, right? And this is also something we want to teach to the students, right? Because we have to prepare them for their professional life. And as we also heard right now, education is time-consuming, so often it was focused on technical aspects rather than on the social factors. But it's super important, especially when it comes to diversity, because teams are slightly getting more diverse nowadays, and so we want to investigate how they are experiencing stressful situations in an educational context. Therefore, we considered 6 diversity dimensions, which you can see here, and we used a controlled experiment where students are exposed to these stressors, and we analyzed their experience. So the first question was, what do students consider as a stressful situation in teamwork, and are they affected by those different diversity dimensions? Now, the good thing is, when you're perceiving stress, this could also lead to some positive effect because you will get some learnings, right? So we also wanted to know, does the learning have some correlation with the diversity dimensions? So as we are dealing with teams, we also wanted to know, right, when you're in a team, how diverse is this team, and does the team diversity itself have an effect on the stresses and the learnings? And the last research question we wanted to ask was, of course, it comes to performance, not just like the feelings, but also does diversity affect the performance, so the quality of work, right? So what have we done? I promised you a lot of suites, that is true. So we wanted to observe the social aspect, that is really important, not the technical ones. So we had no coding class today. We decided to have a really simplified task to focus on the collaboration and the teamwork itself. So based on a prior study, the students, they had to count and sort the sweets M&Ms, as you're all familiar, the small chocolate thingies, in a certain amount of time. And the approach was really self-organized. So we didn't tell them how they should manage with this. The only aim was they should count and sort as many as possible and also document that one. And we did this with 3 kind of stages, with 3 sub-experiments, also based on the Tuckman model. So the first phase was just, as you can see here, they have to sort the M&Ms by their color. Easy, right? Warm up. Second task, or second phase, was they have to sort the M&Ms by color and type, because there are different kinds of sweets when it comes to M&Ms. And the third one, we got the stress level a little bit increasing, because this was the chaos one, as you can see on the right picture. We instructed some students to intervene the team, so to disrupt them. For example, as you can see here, we told them, go to the other team and just eat the sorted items, which the one guy with the blue t-shirt was doing. So yes, and after each of these phases, they had to count the actual number of M&Ms and compare them to what they did in the time. So what did we found out? So overall, we found that a lot of different perceptions are ongoing in all these 6 different diversity dimensions. And the students considered the missing work approach as one of the key stressors. So especially the young students and the male students considered this is the key challenge here, right? We can't figure out how we should do the work approach. Which was also interesting, of course, time was a problem, and also the time management itself, as well as the communication. And these were issues that were often mentioned by female students. So they are, the time is especially stressful for females, obviously. So yeah, and of course, the last point, the external disturbances. As you can see here, again, the guy with the blue T-shirt. And why are they stressful? Yeah, of course, you have a team of like 4 or 5 people. So now one of the team members is only busy keeping the other guy away, so they can't do anything, right? And he had to protect the team and the performance, because otherwise the counting would be wrong. So this was a really nice insult. Overall, the diversity dimension of the social background, so social background in our context means the parents are academic or not academic, or one parent is an academic, has an academic background, impacts the perceived stressors the most overall. Then, of course, the learning. So what did they learn with these stressful situations? So, of course, because we had the work approach, the missing work approach was the most stressful thing, they said, well, within the phases, after some time, we were able to establish some kind of work approach and also some task distribution, because we didn't tell them how to do that. And this was what they considered the most. Relating to the diversity dimension, so younger students experienced a stronger learning on communication and also on establishing work progress, and then they're older ones. And in our context, older means 21 years old, so sorry for you. We've heard last day something else, yeah, sorry. And it was really nice, because in those 2 pictures, you can see they have different work approaches, right? The left one is slightly different than the right one. And one fun fact, which you can keep in mind for one of my last slides, will be the right picture shows our most diverse team. And we had a lot of teams, 65 students, and the most diverse team was the only one where the female students, they were standing. All other participants of our study, they were sitting, so this was really nice, and just keep this in mind for later on. So when it comes to the diversity as a team, so we accumulated all the diversity aspect, we saw that teams with a greater age diversity, a higher ethnic diversity, and also working experience, they had less stress situations, but more learnings. And this is really nice, because so you can say that this is really a good thing for the diverse team. By the performance, we didn't see any significant relationships between diversity of teams in student context and performance. However, we saw that except of the social background, all other dimensions have a medium correlation, meaning that diverse teams, or most of the diverse teams, have an increased performance. So less errors were occurring, and more counted items were there. So to wrap up, software development requires teamwork. It is stressful, and we have to consider teaching it to the students, especially regarding diversity. So therefore, we exposed the students to stressful situations and measured their experiences, our findings include that students are struggling with self-organization, and to our surprise, we found no significant relation between the team performance and the diversity. So the thing is, does diversity matter? I think so, but with our results of our study, it is a little bit more complicated and it depends. But the importance of human factors, especially in software engineering education, should be more valid, especially in the software engineering community. So we really have to do further studies on this topic to provide a healthy and supportive environment for our future software developers. Yes.
Thank you so much, Isabella. We have a couple of minutes for questions. Here, please.
Very interesting. I've been on the side with people doing this, doing Lego stuff with other colleagues, and it's really nice for communication and lots of stuff. But I would like to know if you could perceive anything, any impact, or you discussed that with students after that, because it's software engineering course, really, and if they had any projects where they could apply this. So was there any project after that where they could apply this or learnings that they had? Did you perceive any impact on that?
Yeah, so not yet. It's also something we want to investigate in a further study. But yeah, we had, so the course was integrated in the introductory software engineering course, so really fundamental. They didn't have any teamwork approaches yet. And after the session, we explained our study to them because it was, of course, we didn't say anything, just like, you have to count. And afterwards, we were telling them, hi, why are we doing this? And this was really nice because there was a lot of aha moments from the students. They were like, yeah, that's why I'm feeling this way, maybe, or maybe I should take this into consideration for the next projects. Yeah, but yeah, we want to investigate this further. Thank you.
More questions? Yes, please.
Thanks. So I was wondering, with the analysis of the diversity factors, did you also consider intersectionality, or just like diversity factors separately?
So indeed, for the team diversity, we try to calculate one overall score for the team, right? Because this is really important. But in our analysis, it showed that there are too many factors. We had 6 diversity dimensions, and then we hadn't any valid results. So then we did the approach with separating. But again, we calculated with the Blau index. It's like really common to use this, and this was also something we have for further studies to improve this kind of measuring. How can you measure diversity? Yeah.
Thank you.
Great. There's more questions. I mean, everybody wants to know about the MMS, right?
Yeah. They were really sick after then. They were like, okay, we can't eat any sweets for like 1 week or something.
How did you even get it approved by the ethical review board?
Yeah, you said that you unfortunately didn't measure any effect on the team performance, but I'm wondering if this is the real measurement, because I think measuring team performance, especially when you transfer this to software engineering, is really difficult. So in my experience, I see positive effects of diversity, but I'm not sure how to quantify them. So do you have any insights on that?
Yeah, so from my experience, I would completely agree with you, but the numbers, they were like, as you have seen them. So yeah, maybe we also, yeah. So I think first of all, it's like, there were like 3 hours experiment. So if we have like a longitudinal study or something for 1 semester, maybe we can see more effects, I would guess. And the second thing, is that, yeah, maybe we have to change our way of, or the perspective of seeing, okay, what is quality or performance. So maybe there should be some shift. Of course, we're having, like, there was some paper, so like diverse teams, they are having less smelly or buggy programs, which is quite nice. So yeah, maybe we have to, like, there should be like some focusing or some shift of focusing on performance, right?
Thank you so much, Isabella. Let's give a big round of applause. And our next speaker is Desh.
Okay. Thank Thank you, Alexander, for the introduction. Okay, so my presentation today is about this redeveloped capstone course that we ran at our university. And particularly, it's reflecting on the lessons and experiences from exposing students to large-scale, multi-team software development. And of course, as one of the students mentioned, software is the easy part of the software engineering. So what is the context? Well, all the undergrad software engineering students in our department undergo roughly 5 years of education where they're exposed to everything about software engineering development. But in addition to that, they experience at least 4 co-op internships where they get exposed to real-world software development. Now, of course, some students end up with maybe 5 or 6 internships. And essentially, the capstone course serves as the final milestone that students undertake before they get their degree. So typically, traditionally speaking, students will work in teams of 3 to 5 students working on some sort of software project. And in theory, they would receive very little technical training at that point because, again, it's their last course. So it's expected that even if they don't know the skills, they can learn on their own. However, what was the motivation for our redevelopment of the course? Well, a lot of industry practitioners would report to the faculty or to the department that although the students, when they graduated, they had all the skills and everything, one of the key aspects that was kind of missing from their experience, despite all the co-op jobs, was working in large teams, particularly large teams that involved a lot of inter-team dependencies, inter-team coordination. And so, yeah, even though they worked, in co-op jobs and everything, it was traditionally just linked to 3 to 5 students, less so with 15, 20 developers in that sense. And so this is the reason why we ended up changing the course structure for last year. So the course was ran over the summer, in the summer semester, with roughly 13 weeks, the final week being just final presentations and demoing their final product. Per week, there was a class lecture, which often involved industry panels or assigned readings about certain skills, like, for example, communication or coordination aspects. But in addition to that, students also received at least 5 hours, 30 minutes of lab time per week. And the reason this was set up, and it is a lot of lab time, is because this was time guaranteed where the students could meet in person and everyone is available. Now, of course, some students ended up spending a lot more time in the class, and of course, they were allowed to meet anytime after class. In terms of the actual software development for a project, it was split into four sprints, with each sprint encompassing 2 weeks, so a total of 8 weeks. Now, before that, they also had a mini sprint where it's kind of just figuring things out and getting ready. But the actual software development part was the 4 2-week sprints. In terms of the actual project that the students were tasked to build, for the longest period of time, course scheduling at our university is still conducted primarily through manual means. So oftentimes through Excel spreadsheets, and of course with hundreds of classes, this is a very arduous task. So students were asked to design and implement a university's course scheduler for the software engineering and computer science department. Now, of course, it sounds simple at hand, but then you realize, with any scheduling system, it's actually quite complex, especially considering that they were required to schedule, in essence, not just professor assignments for one semester, but across the whole year. But they also have to take in consideration of where professors may be on medical leave, maybe they're on sabbatical, maybe they have certain teaching preferences, right? They only want to teach maybe a first-year class or a fourth-year class, or they may have certain expertise where only certain professors can teach certain classes. So all those things being in mind were required for the project. Now, in addition to that, actually, is this additional aspect of determining the number of registrants for each course. Now, because depending on the semester, the number of students could actually differ quite a bit because, generally speaking, students are in a certain cohort. So as a result, it's also very important to determine, okay, how many students will actually show up in the fall semester or in the spring semester, and make the appropriate adjustment for the size of the class. Now for the actual project teams, the students were actually split into teams of 19 to 20 students, and we called it a company, right? And in addition to that, the students were further split into 4 smaller sub-teams, encompassing a front end, back end, and then there's actually 2 algorithm teams, and I'll talk a little bit about that. So algorithm 1 encompasses the main scheduling aspect, so the teaching preferences and matching those teaching preferences with the appropriate professor. With the algorithm 2, it's actually assigning the required number of students or the maximum number of students per course. And this is based on using traditional historical numbers of students per cohort to determine those. But in addition to that, so to really get the students to really work out the coordination and communication challenges, each company also had an encompassing paired company of 19 to 20 students. And the theory was that, the idea was that regardless of which submodule we sub out, if we plug and play the submodule of a different company, everything should still work fine, right? So if we take company A and company B, let's say company A's backend or algorithm is not working, we can sub it in using company B's, and everything should still work. So in the terms of project timeline, it's split into 4 sprints, right? So starting with a sprint. First sprint is basically just setting all the APIs up, getting everything set up, and then by sprint 2, it was kind of expected that at least they could get some of the initial schedule generation going, taking into consideration the preferences where professors can could log their preferences, of course, change them and everything. By the 3rd sprint, ironing out some of the issues, and finally the 4th sprint, just fixing everything and ensuring the fully robustness of the projects. Now for lessons learned. So of course with a course with this size of a change, the students obviously had a lot to reflect along with the teaching team. So one of the main things that we found from the student perspective is the importance of culture and trust, especially when you're working on a team of 19 to 20 students, some of some of the students maybe they never even met some of their colleagues. It took a lot for them to really trust that the other students could deliver on what they promised. And of course, what some of the strategies that actually students did is they did a lot of team bonding activities, especially at the beginning. So some of the student teams would actually have weekly, they would go to the bar every week, on a Friday afternoon or something. Or, and of course, from the teaching team perspective, we actually had a karaoke night to, get everyone involved and get to know each other to help build that. In addition to that, we also facilitated a lot of autonomy to the students. So for the most part, it was all self-organized teams where they were given the discretion of how do you want to organize, how do you want to split your teams, what type of expertise do you want in each team, and so on and so forth. And of course, in terms of soft skills, the communication and coordination aspects are paramount to the success of those teams. And it's something that students adapted as the semester went on. So for example, at the beginning, we saw instances where students were meeting a company with another company to work out the APIs. So 40 people sitting together in a meeting. And of course, this was very inefficient, but they kind of adapted and they learned from that, where then they begin selecting just a few students to get on those meetings and then disseminating that knowledge to the rest of the teams. So in terms of for recommendations for future iterations, of course, the icebreaker activities at the beginning were very important. Like a lot of students report at the end of the semester that they made friends, really lifelong kind of friends that they otherwise would not have expected. And that's through working hard throughout the semester with these people that they foster this trust with. And of course, also the ownership and autonomy aspects of the projects, where the students were just given the autonomy to figure out and work out problems on their own. Of course, the teaching team are there if they encounter some major issues, but they were given a lot of that autonomy on their own. Now, from the teaching perspective, the team size could vary with the scope of the project. So, of course, in retrospect, depending on the size, depending on the scope of the project, if it's more complex or less complex, the team size could obviously adapt to that. And another aspect that's really important is the Scrum Master selection. Because the teams were self-organizing, the Scrum Master for each team actually played a significant role because they were oftentimes the person delegating tasks. So the selection of who the Scrum Master was and their amount of experience in that regard could impact the student's overall experience. And so, so for recommendations from a teaching perspective, of course, is just the implementing a screening for students interested in assuming the Scrum Master role. Also, in addition, maybe particularly a component for peer evaluation, because with a team of 20 students, 19 to 20 students, ensuring that each student actually does its fair share or roughly their equal share is quite important. So peer evaluation, ensuring that there's some mechanism to gauge that is pretty important. So in conclusion, we hope that our experience will help influence or at least be useful for other educators to adopt similar course structures or similar capstone projects in their universities. All right.
Thank you so much.
Thank you.
There are definitely quite a lot of questions about this one. Let's start here.
Right.
Hi.
I don't think I've seen any other school that has more co-op commitment than what you just described. 4 co-ops sounds amazing, but I don't think everyone's going to sign up for that. How do you think this would be different in an environment that was more like, hopefully you get one?
Are you saying in terms of in terms of comparison to co-ops, or are you saying?
Yeah, I would anticipate that the lessons and the structure and the efficacy of this approach would be different if the students didn't have that depth of co-op and real-world experience.
Yeah, potentially. I guess that could be one of the things. So I think definitely because the students in the cohort, at that point, they all done basically 4 co-ops, right? So they have a lot of real-world industry experience. It's just that I think there were only a couple students out of the 80 students in the class that really had this large-scale, software development experience. So, in the respect that because they've had a lot of co-op experience, they most likely are probably a little bit more mature in that respect, right? So I think it does depend on the scenario, and it could change. Yes.
If I could add very briefly, I'm the instructor of the course. The 4 co-op internships requirements is because it's part of the Bachelor of Software Engineering accredited program. So it's lovely, wonderful. Anyone who wants to talk about it, please talk to me. I think it would be different. The students actually learn a lot in these co-ops, technologies, infrastructure, deploying your technologies and solutions, right? We would struggle with the autonomy that we require of students to have in this course if they didn't have as many co-ops.
Please be brief.
Since the microphone is close to me and raise my hand. Oh, very nice. I'm going to be talking to you after that. But you said autonomy, but there were predefined sprints. So I was wondering to what extent students had autonomy on that. Yeah. So what the autonomy? Yeah, the sprints were kind of guidelines that how much you want to get done by each sprint, right? And in terms of autonomy, yeah, they definitely had a lot of autonomy in terms of how they organize themselves, how much, how they allocate their work, and they have full autonomy in terms of their technical stack, whatever their APIs, because they determine how they want to negotiate those APIs with their partnering organization, partnering student teams, right? So they have full autonomy over that. We didn't control any of that.
Okay, great. Let us take this discussion offline. Let us thank our speaker again.
All right. Hi, everybody. My name is Lara, and I'm really happy to present the work of me and my colleagues Claudia and Stefan about attribution-based personas in distributed software engineering teams. So to kick off this presentation, I'd like to start with a problem that we as educators specifically, but I think basically everybody in the world experienced in the past years, meetings that previously took place in person had to shift to virtual meetings due to the COVID-19 pandemic. And well, basically, even now that the pandemic is declared over, our life shifted towards more and more virtual meetings. And in that field, research has shown that this specific setting is linked to various potential problems that mainly refer to the increased interpersonal distance and several problems in communication and setup that are caused due to that. And to summarize, one of the biggest challenge in there is due to the virtuality, everybody in the team, but especially the team leaders, which also applies to educators in our setting, have a tendency to rely on their own perceptions and assumptions. And these assumptions and presumptions can be biased because of missing context and therefore affect the relationship between the team leaders and the members. And these misattributions that especially occur on a dispositional level can then again deepen the issues that we mentioned earlier. And this is observed in all kinds of teams, but of course also applies to the educational settings. And in these specific settings, these biases can lead to additional problems that regard the educator-student relationship. And previous research in that field has already shown that the education during the pandemic caused problems such as decreased student engagement, environmental distractions, and in some cases, even worse grading was observed. So in our experience report, this led us to formulate 2 research questions that we wanted to investigate deeper in the field. And we wanted to study the attributions that educators formed, as well as the behaviors and situations that occurred in team meetings that biased the perceptions of the educators. And we also wanted to cluster these findings together and construct personas out of them. For that, we derived 2 research questions, the first one being which perceptions of students are created by the educators in the virtual setting, and the second one, which similarities can be identified between the perceptions of different educators and how can they be utilized to construct personas. And we designed a study to do that. And before I go deeper into the study methods, I want to quickly provide you an overview of the background that we conducted the study in, which is one of the courses that we taught at the Technical University of Munich during the pandemic. And that is called the iPracticum, which is focused on teaching agile software engineering to university students in a very industry-close environment. And to give you a bit of background on that, so in the iPracticum, we usually have about 100 students per semester that participate in different roles. So we would have advanced students that would coach a team and would be considered a Scrum facilitator. Then we have several students participating as developers. Then we usually have a project lead that would be considered a product owner. That role is usually taken over by a doctoral student or a very, very advanced student. And then we would have a customer that comes from industry and research. And during the pandemic, the iPracticum shifted from a previously completely on-site structure to a completely virtual structure in the summer term of 2020, and we therefore considered this course to be a good subject to study the attributions that are formed by the project leader towards the students. In the study, we basically focused on 3 pillars, the dispositional attributions, leadership, and distributed software engineering teams. And we aimed at retrieving new information regarding these topics in conjunction with each other and focused on generating theory from the data instead of just testing theories. And this approach corresponds to the approach of grounded theory. And additionally, we studied these phenomena in a very specific context, namely the iPracticum described before. Our study then consisted of 3 phases that are described in this table. Initially, we had to explore the behaviors that bias the project leader and their judgment and the corresponding perceptions, and therefore we used semi-structured interviews where we interviewed 10 of the project leaders and got to know their observations and possible attributions about their students that they especially attributed to the virtual setting. In the second phase, we took those results of the first phase and performed a questionnaire based on those results, and we clustered common observations by the project leads about the behaviors, and also asked them to rate on the observations that we got to know in the first phase and how well they thought that they applied to them. And at last, we used those results of the second phase to derive personas and basically, give educators and project leads some advice at hand for upcoming semesters. So due to time reasons, I will skip the results of the first and second stage and will directly continue with the most important results of the research, the personas. But before that, I want to give a definition of how we use personas in our context. Basically, how personas are usually described is that they're archetypes used to personify important user characteristics for product design and marketing. Then other definitions include that they're created by analyzing real users' goals, behaviors, and motivations. And the real users' data may come from marketing research, interviews, questionnaires, observations, and ethnographic studies. And to further tailor that to our research, we define personas a bit differently. So we define them as a fictional archetype of team members in virtual teams that are created based on clusters of attributions and motivations, and they exhibit certain behaviors and can be dealt with in specific ways. A short disclaimer. So at this point, there is one thing that I clearly want to state. We only analyze common perceptions of the educators on their students that we created, that were created by them due to the missing context in the virtual settings. This does not mean that the students actually were like that, and these personas also cannot be used to identify real traits or a real context. And our goal was mainly to create these personas to raise awareness of educators that they also might be prone to these assumptions, and they just should be sensitive to these biases and might question when they observe some of those biases on themselves. All right, so let's get deeper into the personas that we actually created. So from the work in the development of the personas, we identified 4 main clusters that were considered bigger than the others, and 3 more minor ones, and we will elaborate on the bigger groups in the next slides. And the main resource for the personas are the attributions included in the survey that I mentioned earlier, and each response of the survey was considered an attribution, and the percent in the pie chart represents the ratio between the attribution of a cluster, for example, 10 in the example of the detached, and the total attributions of the survey, namely 46 of them. And the 7 personas that we derived in the end are the detached, the underperformer, ego is the enemy, the loner, the unprofessional, distraction monster, and hiding and not seeking. So the first one is the detached. The persona of the detached includes attributions by the educators, for example, that they're inattentive and must schedule more times for the meetings. They also attribute that they're uninterested in the iPracticum, the meeting itself, the discussions taking place, and in what everybody else is saying. They would also not prioritize the advancement of the project, and basically the project itself would not be appealing to them. And behavior that is that causes these attributions might be constantly interacting with the mobile phone, joining meetings while engaging in other activities such as walking around, just seeming to be focused on another task, or also apologizing without giving any reason. Then the next persona would be the underperformer. Again, here we have attributions that are formed by the educators, such as lacking the skills to keep up to the promises, being an imposter and pretending to be in the meeting, but actually not putting in the work, not being committed to the project and the teamwork, but also being overwhelmed and being a bit sluggish in the work as well. And the behavior attributed to that is turning on the camera on and off, being too optimistic, or looking quite sleepy or slouchy, and having a disorganized backdrop. The third of the main personas is ego is the enemy. Again, here we have some attributions, like being impolite or disrespectful, And this persona would also be constantly interacting with the phone or engaging in physical activity or having distractions on the outside, like talking to somebody else or interrupting others. And the last one is the loner. Again, here we have certain attributions, like being not involved in the team spirit, being shy or less approachable. And that is caused by behavior, by basically being more quiet than the others, but also by certain conditions like sitting in the dark and barely being able to see that person, and also having audio issues or a bad quality of sound. All right, to conclude this presentation, I want to again highlight our main contributions. So first of all, the most typical dispositional attributions are made with regards to how active a person is and how interested they are, followed by performance, egocentric tendencies, and an unprofessional attitude. And the behaviors that are mostly unaccepted in the meetings relate to distractions and engagement. And the appearance is less judged, and usually technical difficulties are tolerated and understood. And from the results, we also understand that the attributions are frequent when behaviors are inconsistent with the expectations of the educators. And there is also a matter of personal flavor, of course. And now that we know the most typical attributions, more work can also be done on studying the errors in judgment, also known as the fundamental attribution error. Last but not least, if you're interested in all of the personas, we also prepared some supplementary material, which you can check here. And to finalize, I want to thank you for your attention, but also thank again the project leads and everybody participating in the surveys that we used to create or to base our research on. Thank you.
Thank you very much, Lara. First, we have a couple of minutes for questions. Questions? Yes, Sebastian.
Lisa, if you want to go back to your QR code, people can scan it if they like.
Sebastian Brock, TU Delft. Thank you very much for the interesting presentation. Maybe I missed this part, but I'm surprised that you only modeled the negative kind of personas. Aren't there also like positive personas that carry the team by, I don't know, being engaged in the teamwork or by doing a lot of work? And I mean, or like at least seem to be positive. I mean, it seems that you only modeled the negative aspects, but maybe I missed that part of the presentation.
No, that's actually true. That is due to the results or the interviews that we performed that actually mainly contained negative results by the project leads. So there were barely any positive thoughts. So that is definitely something that might be subject to future work. Or should be, but actually in the interviews, the project leads mainly mentioned negative attributions.
Yeah. Okay, just to follow up, because I guess like the problem is that obviously, I mean, you might have negative personas where people like connotate kind of negative attributions with it, but it might also be the other way around, right? There might be people that are seemingly positive, but still don't contribute, and they might get better grades as a result. So I guess it's tricky to distinguish that kind of.
Yeah,
thank you very much.
I think maybe in addition to that,
Please go ahead.
I think the attributions that refer more to positive connotations could be attributions that are also like exhibited in the same way in non-virtual settings. So as we specifically asked for attributions that are caused due to the virtual environment, I think that is why many of the educators mentioned the negative aspects. Because I think like if a person is very active in the meeting, that is something that also occurs in the same way in non-virtual settings. So of course that is a matter of how the interviews would be formulated. But I agree, it's definitely a thing that impacts the grading as well, and therefore should be also studied.
Thank you very much. And I would like to thank our speaker in particular, given the time difference between Munich and Australia.
Hi everyone, welcome to our presentation. I'm Nowshin, this is Kezia, as Professor Sarah Brennick introduced us. And we will be presenting our paper, Leveraging Diversity in Software Engineering Education through Community-Engaged Learning and Supportive Network. So lack of diversity has been a topic of concern for many universities for a while now, as universities face many difficulties in recruiting students from underrepresented communities. And lack of representation, this happens because of lack of representations. The underrepresented students, such as women and other communities, feel that there's a lack of representation and there's a lack of motivation in their undergraduate courses. As such, they tend to go into other subjects and don't tend to remain in STEM fields. Previous research has shown that working in society impactful projects have the ability to retain underrepresented students in STEM fields.
So based on this motivation, we are super happy to be presenting our initiative from the University of Victoria, Inspire STEM for Social Impact. So this is a student-driven program that employs educational techniques from service learning, experiential learning, and design thinking, which is a software development methodology rooted in empathy for the end user. Our program targets students specifically from underrepresented groups, so these may be individuals from marginalized gender groups, racialized groups, and indigenous peoples. Our program has many overarching goals as well, and I'll talk briefly about 4 of them for the purposes of time. First, we're interested in developing a network of like-minded individuals for these students so that they are able to seek support from multiple sources. We also aim to motivate students through empowerment and provide them experience with realistic and impactful problems through community engagement in software development so that these students from these underrepresented groups are able to be prepared to go into the industry post-education. And lastly, we want to encourage students to work well in diverse teams to reduce the diversity problem in software engineering.
So the program consisted of 2 main parts, the students and the projects, which from here on we will be referring to as community partners. Through the help of the Community Engaged Learning Department at the University of Victoria, we were able to recruit 6 community partners whose goals aligned with our program goals. We also recruited 24 students from diverse backgrounds, which we'll be discussing soon, and we divided them into teams of 3 to 4 students. Each team was guided by a senior experienced student who had more experience collaborating or engaging with community partners, as well as we also had industry mentors who guided our students throughout their projects.
So the teams were diverse in terms of many facets. We had a lot of gender diversity. We had female students, those who preferred not to disclose their gender as well. Probably the most diverse field that we had was academic background. So we had students from computer science and software engineering, but as well as many other disciplines of engineering. We also had students from the core sciences, such as physics and chemistry, as well as outside of STEM entirely, from business and fields like gender studies. And they were also diverse in terms of other facets, as I said, ethnicity, personality, so on and so forth. A brief program timeline, just to give you some context. The entire program lasts 4 months, although many students chose to pursue their projects out of interest past these 4 months. So each month was divided into 2-week sprints, which follows the schedule, if you will, of design thinking. So closer to the beginning of the program, we had more of a focus on problem definition, project planning. We had a midterm presentation so that the teaching team could ensure that the students were mostly on track. And towards the tail end of the program, we had a heavy emphasis on validation and solution development.
So throughout these 4 months, we were able to document our students' experiences to understand how the program is going every week or throughout the whole program. So we were collecting individual and team reflections by the end of every week. We also conducted 2 focus groups discussing various topics such as their team experience, their team diversity, and many other aspects. At the end of the program, we interviewed our community partners to understand their perspective of the program. Sorry about that. So the 6 projects that we had in our program were diverse in their own ways. So the first project was a nature sanctuary visitor tracking system. The second project was Women Plus Fleeing Domestic Violence. The third project was towards survivors who were facing a brain injury. The fourth was a climate education for youth. And the fifth was a resource centralization for urban environmental data. And the last one was a website that could track carbon impact of web browsing. So as I said, our teams had very diverse projects, and they had to learn various kinds of skills, such as soft skills, technical skills, to create the solution for their specific projects. However, their overall journeys were somewhat similar. If you want to know more details about each project and their journey, you can read our paper. However, I'm going to just highlight their overall journey, which they expressed as follows. So the presence of real end users and going to the organizations to elicit the requirements, to understand the users, this gave them a sense of motivation, and they were always working towards like finding the solution. They were like, okay, I have to find the solution because there's a real person at the end of this project. However, throughout the whole term, as they were uncovering layers of problems, they felt a sense of uncertainty. At times, they were like, oh, can I actually finish the project? This is a problem that I have to uncover. However, their team diversity helped them a lot because they had different kinds of people, and their different experiences helped them overcome these uncertainty. At the end of the projects, I would say all of our students were saying that this experience or this way of learning soft skills and technical skills were very much efficient when they compared it with a typical classroom project.
So a 15-minute talk will not do justice to how much we learned based on how diverse the students were and how diverse our projects were. So we're going to touch on 4 major lessons that we learned as educators. So the first is that training on soft skills facilitates building a successful network of diverse individuals in software engineering. So a good example of this would be student communication. We spent time actually teaching students about soft skills and their importance, and we noticed that not only did their communication improve within their teams, which was especially important because they were so diverse, but it also improved their communication with their mentors, so they were able to learn more. It improved their communication with their end users, so they were actually able to elicit accurate requirements from their participants and build these successful software products for such diverse causes. As such, we recommend that educators spend and emphasize a significant amount of time towards explicit soft skill training to help students build these connections and develop such a successful network. Secondly, we find that the right amount of guidance empowers students to balance autonomy and motivate them. So this is a bit of a tricky one. We find that at the beginning of our program, students are a little bit uncertain. They don't really know how to interact with their end users, so on and so forth. And this was very overwhelming for them. So us as the teaching team had to step in and guide them a little more, but we did notice as they develop their technical skills, as they develop the soft skills that we just talked about, that they become more confident. And so we suggest that educators adjust the level of support accordingly as your course or program evolves and the students become more experienced.
For our third lesson, as I mentioned earlier, having a real end user and community partners gave them a sense of motivation to work towards the project. However, at times when we spoke to our students and our community partners, we realized that they were lacking a proper structure or like a written document that would help them guide how much to interact with the students. Because we gave them a full autonomy on how to interact, what to do. So at times, the community partners felt like, oh, I don't know how much I should expect from the student. I don't know if I should tell them to build this further or address something else. So the students and the community partners felt like, oh, if we knew how much we can interact, it would be better. Hence, we recommend providing a written guideline or a set of rules, which doesn't have to be strict. You can obviously cater it towards your needs. However, having an initial set of guidelines helps the students and the community partners to engage and make the community engagement learning better. As well as we also recommend adding more instructions and training in communication, negotiation, and scope management, as many of these students were interacting with community partners for the first time. For our final lesson, we would like to address the EDI training. So as we have mentioned before, our teams were diverse, and teamwork in general is very hard, as we all know. However, having a diversity makes it more difficult, and students tend to not understand, why is this person saying this? Why do I have to address this? So at the beginning of the program, we had a EDI trainer from our University of Victoria, who is a professional, trains in EDI training. And our students had to go through this training to understand that, okay, you can have different perspectives, but you don't have to be disrespectful. You can consider each other's perspective and work towards the solution, because that is the main idea of the project. Hence, we recommend including explicit EDI training throughout the program and helping our students to understand and emphasize the benefits of working with a diverse teammates, and as well as be prepared as educators, be prepared to guide them throughout the whole program, because conflicts may arise from time to time. In conclusion, we hope that our program design, lessons, and recommendations can serve as a useful guide for the organizations and other universities who wish to address diversity in their communities.
So thank you everyone for being here. Just before we're done, we have a QR code. So if you are interested more in our program, we're always looking to recruit undergraduate students to be a part of our program, and also for students at any level to participate in tangential research.
Thank you.
Questions, Kiev.
That's very, very nice. Well, I have lots of questions and more things to ask you all. But I saw that you mentioned reflections, individual and team reflections. I would like to know on what basis it happened, if weekly, monthly, and if you analyze that throughout the program to understand their difficulties, and if it was adjusted, anything was adjusted during the process.
Okay, for the reflections, we had a set of, we gave them some questions, initially we gave them an open book, write whatever you're feeling or working on. But then we realized that we need to give them some instructions, and we also gave them training on how to write a reflection. So they were given how is this phase of design thinking going, or how is the teamwork going, how is working with the end users. So there was a set of guidelines for every week, and we improved those or changed those accordingly when the projects evolved throughout the program.
But the feedback, did
you
analyze that's good to know. It was weekly, but did you analyze after that to see if they're having difficulties or something to be adjusted?
Yes,
Okay.
we were analyzing the data every week and then asking them, and we also had to talk to them every week to how everything's going. So it was a constant mentorship.
Hello, first of all, great presentation. It was very interesting. I was curious about the mentorship, if you were able to analyze if the mentorship was diverse as well. So if the person that have very different backgrounds could see them in the mentorship as well.
Yeah, do you want to answer this?
Sure. So that's a great question. So we focused a lot more on the student diversity for the purposes of this presentation. Our mentors were indeed diverse. They came from lots of different backgrounds, and when we submitted a call for mentors, the responses that we got based on what they could provide mentorship on were very different. We had everything from imposter syndrome, being a woman in engineering, to actual technical mentorship. So it was very diverse for sure. And we saw that that was very beneficial for students, because we heard students saying, oh, I learned something from this person when I wasn't really expecting to learn anything from this person, which was great to see that people were learning from, diverse mentors. But in terms of, did we methodologically analyze the mentorship? The answer is no.
Thank you so much.
Thank you. This is Didar Zogi from CSR's Data 61. Great presentation, great work. Thank you for that. Just wanted to bring one point, which is normally related to belonging, because with the diversity and inclusion, often you want to also measure or well, not really measure, but assess whether people who are working in a team feel as if they belong to this team. And this is something that's I often feel that in industry and in practice, people have this problem. So you may bring them from diverse backgrounds together, and you may even give them a chair at the table, as they say, that they sit, and you even empower them to speak and to engage with the conversations in the team. But the issue is that whether they feel they belong to this team. And I just want to give just a pointer that maybe in future offerings, you might like to consider the issue of belonging as well, and see if you can find this kind of information in people's reflections. So if you sort of put some questionnaire in your reflections such that it tries to examine people's sense of belonging and feeling of belonging, because that's also important, especially in industry setting, in relation to whether they remain with the organization or they remain with the team after. If they don't feel they belong, they leave.
Yeah, for sure. In our reflections, we in fact did have these questions, and we also had focus groups where we asked questions about inclusion and whether or not their teams were inclusive, they felt, did they belong here? And since this was a big project, we had different kinds of research going on, like education, personality, empathy. So yeah, for sure, for our next one, we will keep this in mind. Thank you.
Thank you so much. Please stay here. An important point. This was a short session, so we are still waiting for coffee, and I would like to benefit from this by inviting the previous speakers to the front of the room. Chetan, Isabella, Jeshi, please join Nowshin and Kezia for our micro-panel discussion. We only have 10 minutes. But I would like to ask each and every one of you to reflect on what you have seen and heard, because we've been talking about individual training, group projects, M&M eating, and so on and so forth. And I would like to ask people in the audience to ask questions to our panel. And I already see that Dana is eager to ask a question.
I would like to start the conversation about something that I struggle with in my courses, particularly after COVID. How do we build resilient students? And let me unpack what I tried to say is, I like I think Isabella's was the stressors. I think there's a fine balance in how we allow students to struggle and they learn along the way, as opposed to handhold them and making it easy, therefore they're not resilient, and we think they learn something along the way. But I think that it's so difficult to know where that line is so that students actually engage in that struggle in a way that we want them to learn, as opposed to having them frustrated. Anyone has thoughts, best ideas and approaches to this. And every one of you, of course, because I think, Chetan, you also have that in research. You have them struggle in doing something that's new, right? So that's my thought.
So how can we make students more resilient? Maybe you can come to the lectern if you want to comment on this. Comments from the panel?
So maybe just one short notice. I think it's super important to really support the students. And in my point of view, I think it's especially important to have like the safe space for the students. So to have this controlled experience of stress. So not that you're like struggling with the teamwork when it's within the curricula, but like for our experiment, for example, to have really this safe space where we're telling them, okay, it's going to be stressful, but that's part of the game here, not just like that they're feeling alone or something like this. So maybe this is something we can like integrate before they're then going into the wild and struggling with that.
Okay. More opinions from the panel? Opinions from the room? Andrew?
Thank you. I think one thing we're finding successful is using graduated assessment. So we're using a model where what you do to pass is one thing, but what you do to get a high distinction is another. And that's the model that Chetan was talking about, used in research projects there, but we're using it across the board. So the good thing with this, what we're finding is you can scaffold students at the pass level. And as you go to the higher level, you're getting much more demanding, so that then We have students doing sort of individual research projects in first year, first semester, if they're doing the HD level, which we couldn't ask students to do in general because most of them would struggle. But I think that approach is working quite well for us.
Well, this might be cultural, at least. In the Netherlands, many students are stereotyped as aiming only to get a passing grade. And essentially, the ambitious minority will succeed in any way, whatever we are doing with them. But the question is only like, do we really want the slightly less ambitious majority to stick at the level of the passing, or can we lift them up a little bit?
Yes, I think that's where we then come into the dialogue. So part of the model is also frequent formative feedback. So students are submitting things frequently and being encouraged. So we actually so we use this in Introduction to Programming to start with. We found that some classifications, so mostly the female students might not put themselves at the higher level, whereas many of the male students would start off by saying, I'm going to get a high distinction, and then after a while you're telling them, look, you've got to do something, you're going to fail. But we had the other way as well, so some of the female students might not be confident to start with, but then by encouraging and working with them, like they can be encouraged to achieve. Yeah.
Great. Okay, do we have further comments from the panel on this topic? Okay, so then I will give the stage to
I'm really pleased that there's so many discussions here about longer-term projects and project-based learning. I think the elephant in the room, everyone else is talking about AI and ML. We're going to be able to automate all of the math sort of rote material that has been so dominant in our field for so long, and we're going to have to move to more explicit focus on approaches like this. And so I think that the question or the challenge that I would put to all of you is, how do we generalize these clearly high-effort approaches to make this be the dominant paradigm in an undergraduate curriculum instead of the minority? Because I don't think that we have an option. I think we're going to be forced into that.
So do I understand correctly that you are suggesting that essentially the technical tasks should be excluded from the curriculum because AI will anyhow take care of them?
The rote tasks.
The rote tasks.
Taken care of. I've been saying this lately as the AI is going to eat the math, right? The craft is left. But we teach, here's a formal specification for a CS1 problem, and then we feed it to an auto-grader. We don't teach them reading or critiquing or teamwork or design or to talk about design. And I think these are the capstones for that. How do we move everything in that more, I want to see more art studio and less algebra. I don't know.
So the question to the panel, how can we make art to the mainstream element of software engineering education?
So I really appreciate this comment because I'm just going to speak from the perspective of the Inspire program that we just presented on, but definitely I think it was not as, I don't want to say well received, but there was definitely a little bit of pushback when we talk about, okay, we let students kind of just figure out a software engineering project on their own, and then there's a lot of surprise, right, that they're successful. But I think a lot of faculty perhaps just have to actually take the time to see student success. So what we did in the Inspire program was we had many events to actually showcase student success, and we invited people from our faculty, outside of our faculty, to come and see that students really can do this and these novel approaches do work. And I think a big issue might just be that other people are not aware that these approaches work. But I don't know, I would love for someone else to share their thoughts.
Just in terms of individual research projects that I was talking about, I think one of the things that we were focusing on was similar things, like we wanted to focus not on the end product that is built by the students, because then there's a lot of AI that can be used. Like students can be writing their chapters of thesis using ChatGPT now. The idea is to bring the process. You assess the process, not the product. in your assessment process, and also the skills that you want students to have as part of our personas. Because then when you make this explicit, students also, you align the expectations, and students start working towards that when you make things explicit like this.
But isn't it dangerous? I mean, if you are focusing so much on the process, you know, I can have the best cookbook ever, but if I can't cook, if I don't put the right ingredients, I will screw up even my omelette.
True, but also the fact is that I think this is over different courses or units. They will probably get to better products, but what we were focusing, at least in our context, was they were producing decentish products, but they didn't necessarily knew, like, do they even know how to do project management, for instance? Like, if there's a complex project as a part of you, a high distinction graduate from an individual research project, do you even know how to slice a complex research project and analyze that and work on that and things like that?
Thank you so much. I would like to thank also, Ita, sorry. I cannot...
We're turning the other way. So to answer your question, to me the answer is money, right? So, but the other answer is that in lots of disciplines, and say for example in Ireland, in our university we have a graduate medical school, and they do problem-based learning, which is very common in the Netherlands as well. And we as educators have to learn how to teach differently. So it's not just about saying, I will do problem-based learning in my class, which I do and I have done for many years, but I have been on many training courses as to how to do problem-based learning properly. So part of the issue with third level education is a lot of us don't have pedagogical qualifications, and I'm one of those people, and they're being brought in. But I think we really, really, in our world now, have to really think about how can we teach differently, how can we assess differently, and how can we learn how to do that and do it properly, not just say, oh, we'll try this. And like, I'm on sabbatical this year, and someone took over my class, and I get emails about, well, how will I do this problem-based stuff? And I'm saying, you won't do it, just teach your normal way. You know, I'll come back and do it next year because I've learned how to do it.
Great, great. So I would like to thank our wonderful panel of speakers, Martin, who has left us temporarily, and Lisa, our amazing student volunteers, and of course the technical team in the back of the room who have made the Zoom presentation possible. And please give all our speakers and volunteers a big round of applause.